Hello, everybody. I'm here to talk about how there is a way to hide a malicious software inside machine learning model, and how the way they are saved is actually the reason for it. But first, let me introduce myself. My name is Lucija Valentić, and I'm a threat researcher at ReversingLabs, a company that offers software supply chain security and malware analysis platform. So in the last couple of years, we have seen an increased interest in machine learning, of course, with large language models being popularized, ChatGPT-4 being one of the most famous ones. We have seen users and companies alike start creating machine learning models, started creating applications and services using them. We have seen creations of large language models such as Gemini, Llama, GPT-4, and their usage across services, across applications, and platforms. And of course, since a lot of people start using machine learning models, there was also a need for platforms such as Hugging Face and PyTorch Hub to be created. Those serve as repositories where you can store machine learning models, you can share them, you can find them for your own applications, your own services. Last year, Splunk did a research on risks and vulnerabilities of machine learning models, since a lot of people started using them. They focused on Hugging Face, since Hugging Face is the most famous one. And what they find out, that majority of models on Hugging Face are pickle models. And that is a bit concerning, since pickle is unsafe. It can be abused, it can be used to execute arbitrary code, to execute malicious one as well. But we'll get into that a little bit later. First, let's cover some basics. Let me make a brief introduction into what are machine learning models, what they are used for, why they are saved, and where comes pickle in all of this. So, machine learning models are a type of mathematical model that are used for various functions. They are used for object detection, they are used for detection of malicious software, they are used for price prediction, image classification, and so on. They are trained using machine learning algorithms on data sets called training sets. And with each iteration, weights of the model are being better and better, they are being improved with each iteration, and model is performing better and better. And once the model is performing well, is trained, the model is saved. And there are many reasons why you want to save your ML model. For example, maybe you're creating an ML model that is complex. Maybe you're creating it on big data set. So of course, it would take time and computational power to do it whenever you need it. So you create it once, and then you just reuse it again and again when you need it. You also maybe want to share your ML model with other people, maybe with your team members, your collaborators. Maybe you want to offer your ML model to other people so they can include them in their own application, in their own services. So naturally, you upload it on Hugging Face, PyTorch Hub, and so on. You also maybe want to reuse ML model on different environments, different platforms. So when saving ML model, of course, you are using ML frameworks, like doing in general things with ML model, because you're not going to write everything by yourself. And ML frameworks have different libraries for different functions, and they also have different libraries for saving models, for serialization and deserialization. And of course, depending on which kind of model you're using, some may be better for you than others, but also some are more safe than others. And we'll focus here on one particular library for serialization and deserialization, and that is pickle. But you may ask, what is pickle? And how exactly can you find yourself in a pickle? So pickle is a Python module that is used for serialization and deserialization. And here we encounter two concepts, pickling and unpickling. In the process of pickling, a Python object hierarchy is taken and it is turned into a binary system, a pickle. And in the process of unpickling, a binary system is taken and it is turned into a Python object hierarchy. And of course, Python module offers various functions to do various things with pickle. It also offers ways so you can customize parts of it. And that will be important later. But if you want to understand why exactly pickle isn't safe, how it can be used, abused, to execute arbitrary code, malicious one, we want to look at its source code. So when we look at its source code, we can see what happens in the process of pickling and unpickling. In the process of pickling, a Python object hierarchy is taken and it is turned into a sequence of opcodes that represents that Python object hierarchy. And in the process of unpickling, that sequence of opcodes is interpreted by something called pickle machine with its stack and memo that helps with interpretation until last opcode is reached, stop. And there are many opcodes. Some are taking things off of stack, some are putting it on the stack. But two opcodes can be dangerous. Those are reduce and global. They are used in the process of unpickling to import modules and execute them. Those instructions in the process of deserialization invoke function reduce. Now reduce returns all the necessary information for your object to be deserialized. And reduce function, it's not dangerous function at all. It's not unsafe, it's not harmful in itself. But it can be used to, for example, if you want to pickle your own custom class, you will override function reduce, and you will tell pickle how you want it to handle your custom class. Because pickle, there's a list of things it can handle well, that gets pickled well. But for example, your custom class may be pickled in a way you're not satisfied with, or just an error will get thrown. So of course, you override function reduce, and you tell pickle how you want it to handle your class. And here we have one custom class, one evil class, and we have overridden its function reduce. So we have taken instance of that class, we pickled it, we unpickled it on some Linux, and what we got was a host name of that computer that object was unpickled on. Why? Well, because we have overridden function reduce in a way that in the process of unpickling, it returns function OS system with arguments host name. And this is just a simple example, but it is an example that illustrates how exactly pickle isn't safe, how it can be used and abused to execute arbitrary code. Next, we're going to look at some examples of malicious ML models, maybe even some found in the wild. This year, researchers at JFrog have found malicious ML model on Hugging Face. It had reverse shell injected inside. Of course, using reduce and pickle, it was put inside. And once the model was loaded, once it was used, reverse shell would get executed, and then malicious actor would, without victim knowing, get an access to computer so he can maybe exfiltrate data or maybe execute any code. Of course, this reverse shell, that's how the code was written, would get executed either on Linux or on Windows. It didn't matter actually where the model was loaded. And again, this is still a simple example, but it is an example to show that there has been found malicious ML models in the wild, in the Hugging Face. Next we're going to look is a proof of concept is an example, a little bit complex, of malicious model. Researchers at Hidden Layer made a proof of concept, and they found a way to inject malicious software, ransomware, using, again, pickle and function reduce inside large language model. Of course, they also injected a malicious script that would, once the model was used, once it was loaded, it would execute ransomware. And here we have only 2 commands that are necessary to turn a model that is goodware from the start. ResNate 18 is what they used, researchers at Hidden Layer, to turn it into a malicious model that would, once loaded, execute ransomware. The last example we're going to look is something a bit different. Researchers at TrailofBits didn't try to inject some malicious software inside ML model. What they did was a bit different. So large language models in general, also among other things, are used for generative AI. They're used for applications that people use to get some information. And of course, they hope the informations are correct and that are not harmful. So what researchers at TrailofBits did, they, again, using pickle and function reduce, they injected malicious script inside large language model. And once the model was used, once it was loaded, the malicious script would get executed, and then it would change weights of the model ever so slightly, so model would give out some harmful disinformation. And of course, this information, like drinking bleach for a beverage, is very easily to spot, but that may be not always the case. So we have looked at all examples of malicious ML model. But was it all detectable? If you think that some pickle file is malicious, something is amiss, can you detect it? Well, of course. You can use pickling, which is an open source tool developed by researchers at TrailofBits. It's very useful if you're working with pickle. Of course, it's more useful if you're on the reverse engineering side. But there is a useful option, check safely, and you can use pickling and option check safely on some pickle file you think is malicious. Then it would alert you if some function that can be used to execute arbitrary code is used. Another thing that can be used is PickleTools. PickleTools is a Python module, and it offers various commentary on pickle. It offers also some useful functions that you can work with, but it also offers a way you can output a symbolic disassembly of pickle file without actually executing that pickle file. So you as a user, if you think something is amiss, you can see what is being imported and if anything that you are not suspect will be executed. Another thing that can be used, that is already implemented in Hugging Face, is pickle scanning. Of course, like any open source repository, Hugging Face has malware scanning. So whenever some model is uploaded, updated, it gets scanned for malware. But they also have something specific for pickle files. So when some model is uploaded, updated, all pickle files get scanned and all imports inside are written out. And if some import can be used to execute arbitrary code, then that import is highlighted. Of course, it does need to be said that this is not 100% foolproof. Pickle scanning is only writing out all the imports that are used in pickle files. It is not actually scanning all imports. So you still need to do your due diligence, and you still need to check for yourself if you think model can be malicious. And we have seen, of course, some ways to detect if you think something is amiss, if you think pickle files are malicious. But was it all avoidable? Can you make sure that your ML model is safe from the get-go? Can you be sure that some ML model that you downloaded from somewhere is 100% safe, 100% goodware? Well, like with any open source software, if you're not writing it by yourself, you're not always 100% sure it's not malicious. But what you can do, you can maybe avoid loading models from untrusted sources. You can also avoid using pickle files from untrusted sources. And to tackle unsafety of pickle, you can also use something alternative frameworks. As I said before, not all frameworks use pickle for serialization and deserialization. For example, Open Neural Network Exchange uses protobuf, which is one alternative to pickle. Another one is JSON. Of course, depending on which kind of model you're working with, protobuf may be better for you, and maybe JSON would be better for you. You still can choose. And there is another way to safely save tensors. And that is save tensors developed by Hugging Face. And Hugging Face really did their due diligence. They, of course, have malware scanning, but they know that majority of models on their site are pickle models. They also know that pickle is unsafe. So they have pickle scanning, and they also created safe tensors. It's a fast and safe alternative to pickle, and they also offer a conversion where you can convert a model that was created with pickle into a safer version of model using safe tensors. And if you paid attention during this presentation, you would notice that all malicious software would get executed once the model was used, once it was loaded, once pickle was unpickled. So, if there's a way you can customize how something gets unpickled, maybe you can stop malicious software from being executed, or at least detect that it will be executed. And there is. You can customize unpickler, more particularly function find class, to do just that. So find class function, it is called in the process of unpickling whenever some global is requested. So if you override function find class, you customize it, you can ban globals that can be requested, or at least restrict them to a safer set. And one of the examples of unpickler that has been customized, find class that has been overridden, is Krypton unpickler. Krypton is a privacy-preserving ML framework made based on PyTorch, but its unpickler was customized. More particularly, all globals that can be requested were restricted to a safer set that were deemed safe. And that is all. We have seen, first and foremost, what is pickle and how isn't it safe, how it can be used to execute arbitrary code and malicious one as well. We have seen examples of it, and we have seen examples of malicious ML models, some found in the wild, and some perhaps maybe proof of concepts. We have seen applications, tools, services to detect if you think something is amiss, if you think some pickle file maybe is malicious. We have also seen some tools, services, ways so you can mitigate unsafeness of pickle. It does need to be said that all of that is not 100% foolproof. Of course, I have already said that pickle scanning is not 100% foolproof, since all the imports are being just written out. They are not actually being scanned. But there has been research, blogs, academic research, where proof of concepts has been made, explaining and bypassing almost all of them. Of course, protobuf can be abused. Fickling, there has been some proof of concept explaining how fickling can be bypassed. That conversion to a safer version of model using safe tensors can also be bypassed, and not only that, but it could be used to tamper with models on Hugging Face, with different model and different repositories on Hugging Face. What I'm trying to say, unless, of course, you're writing it by yourself, you're not always 100% sure some software that you're using, in this particular case, ML model, is safe, is goodware. You still need to do your due diligence. You still need to check what is inside. Is it goodware? Is it malware? And there are various tools and services to do that. And of course, ReversingLabs has also one service, SpectreAssure, where you can scan ML model and see what is inside. SpectreAssure is a platform, a software supply chain security solution that ReversingLabs offers. And that's it. If you have any questions about this presentation, about ReversingLabs, or in general, if you want to talk to us, feel free to visit us at booth 207. And thank you. That was all.